Kalman's graphical method. This is a graphical method used for determination of lateral earth pressure. So first we will discuss about how to determine active earth pressure. What I am trying to say, active force using Culmann's graphical method. You see, the first one is active force. So how to determine active force using Culmann's graphical method. So that is our discussion for today. So let me explain one by one. First, what we have to do now, first initially we need to draw the wall. We need to draw the wall. Let me draw the wall to a suitable scale, because we cannot draw entire height of the wall on paper, especially on graph sheet. That's why select some scale. Many times, we used to consider 1:100, 1:100. Many times we used to assume 1 meter is equal to 1 meter on ground is equal to 1 centimeter on graph sheet on paper. So we can take the suitable scale. So now you can see this is the height of the wall. But remember that this is we are drawing on graph sheet, and also to taking suitable scale. So now you see this is the height of the wall. This is retaining wall. Now what we have to do now, see this is very important to discuss AB. This is very important to discuss. What is AB? Can anyone tell me what is AB is? AB is back of the wall. AB is back of the wall. Now you see, let me write now. Point by point I will write. I don't want to confuse anyone. Now you see, let AB represents back of the wall. Back face of the wall. Retaining wall. So we are discussing graphical method. So I will write the procedure step by step. This is the first step. First, what you have to do, let AB represents the back face of the retaining wall, and AD represents the backfill surface. So friends, I am going to draw a line AD which represents the backfill surface. So, and also you may ask, sir, so you are drawing the wall. Now back is not inclined. Can you tell me the angle? Yes, I will tell you this angle. So I will choose another color maybe. This angle is alpha. So angle might be the back of the wall with horizontal is alpha. Now the discussion is, so we have a backfill surface. See, now you see the advantage, in Culmann's graphical method is also originated from the Coulomb's theory. So the thing is, here the wall ground surface may not be horizontal, it will be inclined. This is the angle of structure, beta. We have solved one problem also. I have shown you cos beta into cos beta minus. The beta is angle of structures, inclination of the backfill surface, okay, with horizontal. There is no dilemma, this is horizontal. So now this is beta. Now let me show you. So here AD, this is AD, which represents the backfill surface. So I have AB, AD. So this is what the first step is saying to us. So now let me proceed now. The second point, draw BD. I think this is the best way, writing one step and then next step. So instead of teaching all of a sudden, I think it is difficult for you students. That's why I am going one by one. Okay, please bear me for 5 minutes. So I will try to complete it. Okay, next second point. Next second point is draw BD. Now I'm going to draw a line BD. Draw BD inclined at plus 5 degrees with horizontal from B and it meet backfill surface at D. So now I'm going to draw a line. BD. So let me draw this line, but the line is going to be drawn like this. So with an angle plus phi. So you may ask, what is phi? Phi means angle of internal friction. So here what we are going to do is we are going to draw a line BD with an angle plus phi. Okay, so now you can say, to be frank, it is anti-clockwise direction. Now see, I'm going to the next step. Probably I am trying to manage like this, so because otherwise you may feel difficulty. So now, yes, it is visible to you now. I'm thinking about you people only. Now the third step. Yes, it is visible to you now. Yes. Unless until if it is not visible, I cannot ask any question, and I cannot get anything from you people. So now it is visible. So I'm going to discuss with you people about the third step involved in determination of active force using Kalman's graphical method. So far we have drawn back face of the retaining wall, and also we have drawn the phi line. This line actually we used to call phi line. So just now we have drawn phi line. Okay. Now let me proceed. Now draw BK. Draw BK inclined at psi. Let me write, this is psi. Psi is equal to alpha minus delta with BD. So now you see here, you see which is psi line. This is very important. We need to draw. This is phi line. So now it is the time for discussing psi line. So let me draw it, I think. Hope it is visible to you. So now I am going to draw a line, psi line, with an angle psi is equal to alpha minus delta. ఇప్పుడు మీరు అడుగుతారు, సార్ ఏంటి ఆల్ఫా? Alpha is the angle made by the back face of the retaining wall with horizontal. Delta, ఇది మీరు చెప్పాలి. What is delta? You need to tell. So please tell me what is delta. Okay, మీరు నాకు చెప్తారు కానీ. Now let me proceed now. So మీకు కనబడేలాగా నేను చూపిస్తాను. So now we are moving to the next point. Now the fourth point. Now choose an arbitrary failure plane. Choose an arbitrary failure plane. Now I am selecting one arbitrary failure plane, BC1. Calculate weight of wedge AB, soil wedge ABC1 and plot. Even last class also we have discussed. Now we are just and plot it as B1 B-1 to a convenient scale on the file line. So now what I'm going to do now, so I will keep like this now. Okay. So now choose, see, I have line and as well as file line. So this is BK, this is BK, this line is line. Now you see, choose an arbitrary failure surface. So let me choose one arbitrary failure surface. So right now I'm selecting this C1, ABC1. This is the sliding wedge, the first sliding wedge, arbitrary sliding wedge I have considered. You can call this weight is W1. So yesterday also many of students has given a wonderful reply about how to calculate weight. As you know, here you see W1 is equal to gamma into ABC1. So whatever the weight you got, you may get some answer in kilonewton per meter. That you need to locate here. So let me write B1. So you see here it is B1. So now B1 is equal to, this is equal to B-1, weight. So I just converted weight into a linear measurement. What I have done actually, so I have converted a parameter which is in equivalent units of weight is converted as linear measurement. So B1. So this is what happened. You need to take B1 to a convenient scale on file line. So now you see what we have to do now. So what we have to do now, the next point. Okay, I think now it is visible to you. Now you see the next point. Draw 1 dash parallel to sideline. Draw a 1 dash. This is the symbol of parallel to sideline through 1 to meet BC1 at 1 dash. Okay, now 1 dash. So you know that 1 dash is the point on the curve. Now what I have to do now, I need to draw a line. So now you see what I'm doing now. So here you see I have sideline. Hope it is visible. Yes, this is sideline. Now just move parallel to it. Draw a line 1 dash. So now it is parallel. So this 1 dash. So this 1 dash should cut your arbitrary failure surface. So now this is the way we are getting 1 dash. Now 1 dash is the point on the Kalman's curve. 1 dash is the point on the Kalman's curve. Now in the same way, you should now repeat the same procedure. So now you see, similarly you can repeat now. I can write because I know it is better to write. So now similarly takes some more failure planes. So you can choose few more failure planes. BC2, BC3, so BC4 and so on, etc. So now you can choose as many as it is up to you, and repeat steps 4 and 5, 4 and 5 to establish points, 2 dash, 3 dash, 4 dash. So this is now, it is very important. Now the last one, join 1 dash, 2 dash, 3 dash and 4 dash, because we have considered 4 arbitrary plane. Join 1 dash, 2 dash, 3 dash, 4 dash with smooth curve. This curve is called Culmann's curve. Culmann, Culmann's curve. So probably I think now we are going to write. So now you tell me what is delta. Delta is angle of wall friction. Delta is angle of wall friction. Now you see what I am doing now. See, I am considering one more failure plane. What is this? C2. Considering one more C3. Considering one more C4. Now what I have to do? I have to do calculate W2, W3. Now 1, 2, 3, 4. So like this 5. Okay. So now you can see here what I am doing now. I have to consider second point now. Again third point. Again fourth point. Again fifth point. Now what is B1? Can anyone tell me what is B1? B1 is W1. What is B2? W2. What is B3? W3. What is B4? W4. Now what I have to do now? Next step. So next step is very clear. You see here. Now you see, similarly take some more failure planes. Yes, I have considered some more failure planes. C2, C3, C4. Yes. And repeat the steps. Yes, I have repeated already. Now what I have to do now? I need to draw lines parallel to side line. Can anyone tell me now how to draw now? How to draw? So I need to draw lines parallel to side line from 2. So and also whatever the line, it has to touch the failure plane at. Can anyone tell me now what is this point now? 2 dash. So I think I need to think about visibility. So this is 2 dash. So now can anyone tell me what is this line? What is this point? It's your time. Probably see I'm getting here 4. Okay, it is touching here 5. So now this is 3 dash, 4 dash. So now you see here 3 dash, 4 dash, 5 dash. Now you see, I will do one thing. I will select another color. You know, here the difficulty, 3 dash, 4 dash, 5 dash. Now I'm joining these line points now with a smooth curve. This curve is called Kalman's curve. Kalman's curve. So now what I'm doing now, I'm trying to draw lines parallel to side line from 1, from 2, from 3, from 4, from 5. So whatever the line, it has to intersect the already drawn arbitrary failure plane. If it is the first failure plane at 1 dash, if it is second failure plane at 2 dash, if it is third failure plane, it will intersect the point which is called 3 dash, 4 dash. Now join all these lines. This is called Kalman's curve. Kalman's curve. So now maybe because of these colors you may find difficulty, but please understand the procedure is clearly written. I will send the material to all the students. So Now you see here, this is the Kalman's curve. Now next step, now draw a tangent TT. I will write, I think. Now the next point, 8th point, draw a tangent TT to the Culmann curve. Parallel to phi line. So there is no issue now. See what we are going to do now. We are going to draw a tangent. So let me show you now. So I will use only pen only. Parallel to phi line. This is phi line, you know. So I am drawing a line parallel to phi line. So this is tangent. You know, tangent means it touches the curve at one point only. So which is parallel to phi line. So this line is parallel to phi line. Now this point is f dash. This point is f dash. So now what I have to do now? Draw a line parallel to psi line, which touch the phi line at f. Now f dash f is PA. So now you can see here f dash f is PA. This f dash, you know that that is the point of tangency, f dash. Now I will write because we have to write. Now I think yes. Now you can see now. Now draw f dash f parallel to this is the symbol I am using, parallel to psi line to meet phi line at f. Okay, now the last point, join now this I don't think so. This is enough now. F dash f is equal to active force. Now you can write now if you want to write B f dash C is the B f dash C represents the failure surface. So, what I'm trying to write now, you see here I'm not going to use a sketch pen because a sketch pen will definitely creates a problem here. You know the what problem I am facing now. So now you see this B f dash C is the failure surface. So the point, the touching heel B f dash C is the failure surface. Anyhow, this figure is maybe you may feel it is clumsy. That's why I have another option also. So now you can see here. So I will present you. Yes. This is the figure. I think this is also okay. I will do one thing. I have a lot of options. Now you can see here. It is very clear. Now you can see what I have done now. So here you see delta is wall friction. I am teaching Kalman's graphical method in case of active earth pressure. You see the way actually what we written in the same way it is there. But here you see we have phi line, and we have psi line. First we need to draw the retaining wall to the scale with proper inclination of the back surface. Here you see I have shown you alpha. In మీకు ఆల్ఫా చూపించానండి. ఇక్కడ ఈయన టీటా అన్నాడు. ఏదైనా ఒకటే అర్థం ఒకటే. ఇక్కడ మీరు whatever we written here, you might be known psi is alpha minus delta. Meaning is same because you know, very interesting to know, theta is 90 minus alpha. So 90 minus alpha. Now you can see here, whatever we are saying is, so 90 minus alpha is, now the total is alpha minus delta. So now here you see what I have done actually. I have drawn the back face, and also I have drawn the backfill surface initially. Then I started drawing one line. Actually, I started drawing one line at heel, so with an angle phi. So now after that, I have drawn psi line. Once this thing is completed, I have considered initially one failure surface. You can see here one failure surface. So I can able to calculate its weight. As you know, weight is gamma into area. So that is the reason why I am drawing on graph sheet, because in graph sheet I can able to measure the area. I can get the area. So that's why actually I want weight. So weight is gamma into area into 1. So area is given by once we are tracing the diagram on graph sheet, we can easily measure the area of the sliding wedge. First portion. Then similarly take another failure surface, W2, take another failure surface, W3, take another failure surface, W4. But don't forget to show these lines. These I'm trying to assume actually as 1, 2, 3, 4. You might be observed there. So 4, 5 like that. So once while I'm locating B1, so this is my B actually. B1 is equal to W1. B2 is equal to, and also now I am drawing a line parallel to psi line, which intersect this arbitrary failure surface, first failure surface at 1 dash, again at 2 dash, 3 dash. Now draw the line combining 1 dash, 2 dash, 3 dash, 4 dash. Now this is Kalman's curve. Now you need to draw a tangent, because tangent, from tangent you can able to know the curvature, point of tangency. So once you know the tangency, we can able to get this f dash. So and one more point, while you are drawing the point, this tangent, your tangent line should be parallel to phi line. So now the thing is, now we have f dash. This is the point on Kalman's curve. Now draw a line parallel to psi line. See here we have two lines. One is phi line and psi line. Now draw a line parallel to psi line. So now which intersect the phi line at f. So I know I have f dash and f. This f dash, f is the PA. F dash, f is the PA. So now this is the way we use it to. Now someone can ask me, sir, what is the failure surface at the end? So try a line now P. I think yes, I'm finding difficulty because you know what problem I am having. I don't have any digital pen. So now you see here I am drawing now. Now I am connecting a line now with B. Yeah, I think. With B f dash C, this is the failure surface, final failure surface. So with this, I think you understand Kalman's graphical method. But now you see in passive case, what we are doing now, if you want to calculate passive force, same way, draw the retaining wall to the scale. But what I am trying to say, please keep this point. Whenever you are drawing phi line, draw minus phi line, minus phi. That means you need to draw phi line in clockwise direction. Now from phi line, draw psi line. But remember this time psi is alpha minus, if you write minus, it is active, alpha plus delta. I will repeat once again. Now we are discussing passive earth pressure. Whenever you are discussing passive earth pressure, we need to draw phi line. First you draw the retaining wall, whatever the retaining wall to the scale, suitable scale. After drawing the retaining wall, you start at B. This is what my B point. So so once we need to draw at B, we need to draw phi line and psi line. First you draw phi line, but don't draw plus phi line. Now don't draw this. This is active case. When you are dealing with passive case, draw minus phi line. So after drawing minus phi line, now draw psi line with an angle alpha plus delta. Alpha plus delta. So now the same procedure you can repeat. The same procedure means I am not skipping. Select some points on phi line. 1, 2, 3, 4. You know how to proceed further. After selecting points 1, 2, 3, 4 on phi line, what I have to do now? So how I will say B1, B2, B3, B1 is equal to W1, B2 is equal to W2, B3 is equal to W3. So repeat the procedure and now draw the lines. You know how to draw 1, 1 dash, 2, 2 dash, 3, 3 dash. Now here you see there is no surprise. Your psi line is like this. That's why your 1, 1 dash, you see your 1, 1 dash line is like this. This is your 1, 1 dash. This is your 2, 2 dash. This is your 3, 3 dash. I can explain. I'm not actually skipping this. I have that guts to discuss this 4, 4 dash. Now join these points 1, 1 dash, 1 dash, 2 dash, 3 dash with the smooth curve. Now you can see the curve passive. This is the Kalman's curve in case of passive earth pressure. So now draw a tangent same way. So draw a tangent parallel to phi line. Parallel to phi line. This is the tangent. So now what I have to do now? So I got the point of tangent C. This is f dash on Culmann curve f dash. Now what I have to do now? I need to draw a line parallel to psi line, which intersect the phi line at F. Now can anyone tell me what is FF dash? FF dash is equal to FF dash is equal to. Can anyone tell me what is FF dash? FF dash is equal to PP. Passive force.